Welcome to another amazing episode of FinStecks. Today we're diving into something pretty wild, actually. A world-first half marathon over in Beijing, where humanoid robots, well, they ran alongside human runners.
Yeah, quite the spectacle.
Mm,
Really makes you think about where this tech is heading.
absolutely. So we've looked into this, and our mission today is basically to unpack what went down. Not just, which robot won, but what does this tell us about the technology? The leaps forward, but also the challenges that are still clearly there.
Exactly. It's a fascinating case study in current robotics.
Okay, so let's get into the basics. It was a 21-kilometer race, a proper half marathon, and there were 21 humanoid robots taking part.
21. That's quite a field.
Yeah, and the winner of the robot division was this machine called Tiangong Ultra.
Tiangong Ultra.
And get this for size. It's 1.8 meters tall, weighs about 52 to 55 kilos.
So roughly human size, then.
Pretty much.
Yeah.
Which, as we talked about before, that height probably helps with stride length, right?
Oh, definitely. Longer legs, potentially a more efficient gait for covering distance. That makes sense?
And it's winning time. 2 hours and 40 minutes.
240.
Yeah.
Okay, so not challenging the human elite runners just yet, but still, completing the distance is the key thing here.
For sure. And it wasn't just shuffling along. Its usual pace was like 7 to 8 kilometers an hour. But apparently, it could hit bursts of up to 12 kilometer.
Wow, okay. So it had some speed variability that suggests some pretty sophisticated motor control and power management.
Yeah, not just a steady plod. It even looked the part. Bright orange tank top, black running shoes.
Huh, really? They dressed it up.
Yeah, had its name on it and everything. But here's the kicker. It needed 3 battery changes to finish the race.
Okay. There's the reality check.
Right.
3 swaps. That's...
Well, it's significant. It tells us
Yeah.
a lot about the current state of battery tech and energy efficiency for these kinds of demanding tasks. Sustained power is still a huge hurdle.
No kidding. Unlike human runners just grabbing a drink or a gel.
Exactly. You don't need a whole new power core mid-race. So what made this Tiangong Ultra win, then, apart from the look?
Well, according to Tang Jin, a CTO at the Beijing Humanoid Robot Innovation Center, it came down to 2 main things.
Okay.
Those long legs we mentioned for stride and a specialized algorithm. Apparently, it was designed to mimic how humans run marathons.
Mimic humans. So trying to be more biomechanically efficient.
That's the idea. Instead of just programming run forward, they're looking at the nuances of human movement, trying to replicate that efficiency, and maybe conserve energy better between those battery swaps.
Interesting. And it wasn't just software tweaks, was it? There were hardware upgrades, too.
Right. They mentioned better joint stability, which is crucial when you're pounding pavement for 21K. Also, better heat resistance electronics get hot and shock resistance.
Makes sense. That repeated impact would take a toll.
Absolutely. These physical upgrades are vital for robots operating out in the real unpredictable world. Better stability, managing heat, handling shocks. It all adds up to reliability.
And they also talked about an upgraded motion control algorithm. Something about handling different road surfaces.
Yeah, that's another key point. Real-world surfaces aren't uniform. So the robot needs sensors to detect changes, maybe rough patches, maybe slight inclines, and adjust its gait in real time.
So it's adapting on the fly.
Exactly. It shows progress in perception and reaction, not just following a set program.
Then there was this platform they mentioned, Husikaiwu, described as a universal embodied intelligence system. That sounds ambitious.
It does, yeah. And apparently it made a massive difference. The robot's previous top speed was only 6 kilometers.
Whoa, so this platform basically doubled its potential speed.
Seems like it. The term universal embodied intelligence suggests maybe more general-purpose AI for movement, allowing it to learn and adapt more broadly, not just for one specific task. Less programming, more learning.
Like giving it a smarter movement brain.
Sort of, yeah. It could be a big step towards more versatile robots.
Okay, let's talk about those battery swaps again. Because it wasn't just about swapping them, there was a penalty, right?
Yes, a 10-minute penalty for every swap.
10 minutes. So that has a whole strategic element. You can't just swap whenever you feel like it.
Precisely. It forces a trade-off. Is the fresh battery worth the time lost standing still? Teams had to calculate that. It's like pit stop strategy in racing.
Yeah, good comparison. And this whole battery swap idea, it's not just for robot races, it's happening commercially.
Oh, absolutely. Think automated warehouses, logistics, robotic arms, swapping batteries and dedicated stations to keep robot fleets running with minimal downtime.
We saw some stats on that, like one station managing up to 100 robots, over 99% uptime. It's pretty slick.
It really is. And charging times as low as 12 minutes per battery, that level of efficiency is what makes large-scale robotic deployment feasible in industry.
And it's even happening with electric vehicles in China, right? Super fast swaps for taxis and trucks.
Yeah, like 2 minutes for a taxi, maybe 6 for a truck. Faster than filling a gas tank. It shows the tech is mature and viable for keeping things moving, whether it's EVs or potentially endurance robots.
Okay, but back to the race. It wasn't all smooth running. They had safety measures,
Yeah,
obviously.
I'd hope so.
Yeah, separate lanes for the robots, divide by barriers or green belts, and they didn't start them all at once. Sequential starts to avoid a robot pileup at the beginning.
Sensible precautions. Especially for a first-time event like this, running alongside people, safety has to be paramount.
Still, there were glitches. One robot apparently just fell over at the start.
Woo!
Took a few minutes to get it back up. And another one crashed into a railing, made its human operator trip up.
Ah. See, that highlights the ongoing challenges. Stability, obstacle avoidance, robust navigation in dynamic environments. These are still tough problems for humanoid robots. Even a simple railing can cause issues.
And they had aid stations, but not for water, for batteries. 7 of them.
Like Formula One pit stops, as you said.
Yeah. Manned by support teams, presumably trying to do those swaps as fast as possible to minimize that 10-minute hit.
It really emphasizes the logistics involved. It's not just the robot, it's the whole support infrastructure needed to keep it going.
And even the winner, Tiangong Ultra, needed 3 of those stops. 3 battery changes.
Which brings us back to that core limitation, endurance. As impressive as completing the race is, relying on multiple external battery swaps shows we're still a way off from matching biological energy efficiency and duration.
So looking at the big picture then, what's the main takeaway from this whole event? It feels significant, this being the first time robots ran a half marathon with humans.
I think it's a very visible marker of progress. It shows how far humanoid robotics has come in terms of mobility, balance, control systems. Tiangong Ultra finishing, even with the swaps, is genuinely impressive.
God.
But yeah, those battery swaps, the falls, the crashes, they're important reminders of the hurdles still ahead. Achieving human-level endurance, reliability, and adaptability in unpredictable settings. Still a major work in progress.
It does make you think about the humanoid form factor itself. Maybe great for versatility, but perhaps not the most energy-efficient design for pure endurance.
That's a really interesting design question. There are always trade-offs. What this race shows is that progress is rapid, but the path to truly autonomous, long-duration humanoid robots is definitely still ongoing.
So where does this leave us thinking about the future? I mean, this race is a cool snapshot of robotics advancing, finding clever ways around problems like battery life.
It is, and it inevitably makes you wonder, what's next? If they can run a half marathon today, what other human activities might robots participate in down the line?
Right. Sports, maybe other complex tasks, and what new challenges or opportunities pop up when they do.
Exactly. It opens up questions about human-robot interaction, integration into society, the types of tasks we might see automated. This Beijing event, it definitely gives us plenty to mull over.
It really does. Lots to think about there. Well, that's our deep dive for today. Don't forget to like, subscribe, and share, and stay tuned for more exciting stuff.